Hey guys, so today I'm going to do another little live coding video of me using Go and Emacs. So this is actually one of my public repositories on GitHub, and I tried running this code and I got a panic. So I've already been looking into this a little bit. I'm pretty sure I know what's causing it. So you can see panic, it's trying to open this file inside a subdirectory. If I just do a quick ls, you'll see that that directory is not here. So the problem causing this error, it's not no such file on the file, it's no such directory on the parent directory. So that's what's causing it to panic. We can follow this stack trace if we want. I'm already in main.go. If we jump to 656, we'll see this call is prog.run. If I follow that, it takes me to an interface, which is a little annoying. Okay. But I know that this is in molpro.go. Yeah, where the next line of the stack trace shows us. If I jump to 376, the problem is when I try to write a PBS file, and then in pbs.go, line 63, this is where the panic originates when I try to actually open this file. Okay, so the way I have this is I have a function called make. Let me turn on screen key again, just so you guys can kind of follow along. So what I'm calling right now, Control-C-G, I have bound to something you can't even see now because of screen key, but I'm calling consult-ripgrep. So what this is going to do is recursively grep through my project for the pattern I'm about to type. And in contrast to the Emacs, alright, I can fix this. Let's not put it right at the bottom. How do I do this again? Select. Okay. I'm just going to put it right, how about right here? Okay, perfect. Alright. So Alt-X. This is different from doing rgrep that's built into Emacs. So if I rgrep for write PBS, for example, yeah, it's just going to prompt me for all this stuff. And it does recursively grep, but you see it gives me this buffer. So then I need to go over to this buffer, and I can like click on this stuff. But what you'll see when I do consult-ripgrep is it's going to build that list, and it's going to like show me the previews of this stuff. So what I'm actually looking for is make dir, because I know that's what I called it. So you can see here's some places where I'm calling it. This is a little annoying because it's inside of my notes file. So make dir, test make dirs, the return, and here's where I actually define the function. So I just scrolled through that with consult, and it showed me that. So the problem is that these directories are not getting made before I try to write a file into the directory. So without going into too much detail about what this program does, basically there are three big cases. One is like SIC or SIC, which stands for symmetry internal coordinates. So that's one coordinate system. Another option are Cartesian coordinates, so do carts. And then we've also got gradients. So we can do like energy Cartesians or like gradient Cartesians. And again, it's not too important to the actual coding issue. And you can see if we're doing Cartesians or gradients, we don't make this op directory. So the essence of what I need to change here is just add, I need to make Cartesians and optimizations not exclusive. So I want a check like this, then dirs equals opt. So I'll always make your opt. And then I should, in here, I'm going to change these to append. So dirs equals append dirs, comma this. So then I can do the same thing down here. So now the opt decision is before the other two. Oh, I see what I did. Dirs, okay. Okay, so in this case, if it's Cartesians or gradients, I'm just going to append points INP. And otherwise, I'll make these. Now that makes sense. However, something else I wanted to change here So I'm sure this is going to run the test just fine. Compile. So I used Emacs compile. This is how I compile stuff. I think I maybe didn't talk about this last time, but I'm just going to run make test, and you can see what that expands to. So I have a script that basically extracts the version of the program from the Git history, so that at the top of the output file I can print the version that's being run. Because I do a lot of active development on this project, and it's helpful to know what version I'm dealing with. You can see I should have run the short tests, but basically all the tests are going to pass. There's no problem here. I should have run the short tests. But anyway. Oh, beautiful. Yes. Yes. Oh, that's good. Actually, I did have a test for this. So what I was afraid of with this kind of thing, let's go look at what do-opt is. So if I hit GD, I can jump to definition. I can also do meta period. That's like xref find definition. Something I just learned about that's really handy too is xref find references, which is on alt shift or alt question mark. So we can find references in do-opt. You see it actually only gets called twice. Yeah. So if I jump to do-opt, you see that I was being fancy here, and I'm using a bit vector for the flags. So I've got this vector called flags, which is just an integer. And when I want to set these, I'm doing like bitwise operations. That's very cute, but as you can see, that makes, I hate these. So let's get rid of those. And so today we're going to see how Go's static typing is very helpful at doing refactors like this. So I'm going to just delete all of these. I'm going to change the types of these flags to booleans, and then we're just going to follow the compiler to help us track down everything that gets broken with that. So first things first, let's get rid of this. I've actually done this once before I started recording, so I kind of know what's going on here. So I'm just going to do a visual select, Shift A, add bool to all of these. Okay, apparently it didn't quite work. Wait, alright, so I need Control V, $A, bool. Alright, let's get a little cuter. Alright, there we go. Missing constant. Yeah, so they're not constants anymore, now they're variables. Alright, we're all funked it up. Again, I'm working on the small keyboard, so Control C6 is my Go funked. That's usually bound to F6. Okay, so compile. Let's see what happens. So now we've got all these things that are undefined. I also know that I actually don't have one for sick here for some reason. So everywhere I had do sick, now it's going to replace with sick. Let's hop over here. Undefined do sick. So I did CF paren to change to the right paren. Those errors should be done. Okay, so now I can't do bitwise operations on booleans. So now all I have to do is cart equals true, grad equals true. Beautiful. And I'm actually, another thing I can do is, let's go to definition. Oh, apparently that's symbol at point. Alright, extra find definition. Oh, okay, it's only at point. Alright, so this is where the ripgrep comes in handy again. So I want flags. How about var flags? It's not going to be that one. Here. Full test. Here. Flags. Yes. This. Delete. Get rid of that. Undefined flags. Now that will pop me up to everything. Where am I? So I'm pressing ZZ to center my center the line I'm on in the middle of the screen. Oh my god. Alright. So look at this stupid bitwise operation. Opt equals false. If we find no op, don't op. Easy enough. One really handy package that I'm going to talk about very shortly in the Emacs from source series is ynum. So that's how I'm jumping between windows with just meta and then 1, 2, 3 and so on. Alright, if freaks equals true. So in this case I want points to be true and freaks to be true. Equals true. Points, freaks, and op equals true. Okay. So apparently I actually set this in parse flags. So let's see. This is going to answer my question. So I call parse flags before I call initialize, which is what calls make ders. So our change in make ders should work. This part should work once I update it like this. I know, I don't think it's really idiomatic in Go to use these all caps, but I usually kind of do that for, sometimes I do it for global variables. Let's try compiling this again. Okay. So one thing I dislike, or that I find a little surprising about, actually maybe this might be a good time for projectile. Let's see, Control CP is my projectile binding. So we want to projectile find and replace. I've never actually done this, but it seems like the kind of thing you should be able to do. How about projectile replace? Oh, neat. Do grad with grad. Let's see if this works. What? Did it work? Where'd it go? Oh, okay, that's pretty cool. Can you do that with LSP too? Replace? No. LSP replace? I know you can do LSP rename, right? Like I can do RR on this. The problem with that is that it doesn't work on function calls. Like let's try to do that with do cart. Yeah, LSP rename is actually, yeah, because it's undeclared. So in this case, we actually want something that's a little dumber than LSP mode. So LSP can't figure out that that's like an undeclared function, but we can do this with projectile. So projectile replace, yeah, do cart with just cart. And then it's actually querying me. I guess that's nice. Recompile. Okay, so let's keep doing that. PR, do sick, sick. Yes, 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 yes. There's probably a way to make it not prompt me, but I don't really mind. I didn't catch that one. Oh no, that's a different one. Okay, do opt. Okay. Oh. Okay, the one downside of this is that now those procedures are all defined separately. So I can't temporarily change some of them. Well, we'll see what tests it breaks. So just to show, to show the kind of idiom I'm doing here, since I'm relying so heavily on these global variables, for many of the tests you want to be able to control the values of them. So what I'll do is I'll capture the initial value, and then I defer this function that sets it back to its initial value inside of the function. Okay, we may have to... Okay. Yeah, we're gonna have to take care of this. Oh boy. Okay. Flags. What is this? Oh! Okay. So I'm actually going to delete this whole test. This test is basically... yeah, this test is checking if I knew what I was doing with my bitwise operations. So now that we're not doing those, we should be able to do this. Whoa. Oh no. Looks like enter may not be initialized actually. Yeah. Okay. So I'm actually calling enter. Oh, very interesting. So now, okay. This is some flag problem, I'm sure. Ah, yes, it's because, okay, so, where's my defer? Sec equals true, defer, sec equals false. We're probably gonna have a lot of problems like that. Or not, we only have one. Here we go. Test resub. Oh. Wrong panic. Oh boy. Oh, stupid thing. How much can I move this? Oh, okay. So where do we actually panic? So I guess I'll talk a little bit about what's going on here, because I think it's kind of cute what I'm doing. So my program has this facility where it can resubmit an incomplete calculation. So to test that, I am intentionally, I'm returning this closure that after 24 iterations panics. And when it panics, of course it crashes, but Go has this thing that you can do where you can defer a function to recover from a panic. So I cause this panic, but inside of the test, I catch the panic and then resume. So this is me calling the resubmission code, which I think is pretty cool. Probably you don't have to do it that way, but that's a fun way to do it. Okay, coaf. What's the problem? Wrong panic. Ah, my gradients is not. Okay. So, yes. So one other thing, Control T. Oh, that's not what I wanted. I want Control O. So this jumps you up and down the tag stack. Not tags, like marks, I think. Let's see. Evil jump backward in the jump list. Press tab. What? Control I takes you up. So I'm at the top of the jump stack. But yeah, you can like old I, O I. That's something to keep in mind even in Vim, because that's from Vim. I think Emacs has something similar, but I just use the evil mode version. So we caught the wrong panic. The panic happened here when we try to index into gradients. So it's trying to check the gradients even though we're not in grad. So when I'm doing this, I'm doing Cartesians. So I want to set the problem. This is caused because the gradient calculation is just before it. So grad's getting set to true. So here I want to set grad equals false. Let's see if that works. Yeah, I'm not really happy with the use of these globals, but I was even less happy with the bit vector that I just decided to use. I was trying to figure out how they worked, like using flags like that, and it's really cool. It's just not really applicable here. Okay, good. Now we're back to the actual test failure that brought us to this. Failed to create. Yeah, great. All right, so I'm going to go ahead and commit this because this took care of the refactoring. Okay. Refactor to avoid bitwise flags. Okay. Now let's turn to this actual problem. So we failed to create opt and test files. There's so I'm expecting opt to be true, and opt is not true. So just to check that, let's go ahead and print opt. And this time I will compile with short. So I have a makefile set up for this. I can say short equals 1. Yeah. There are actually 5 test failures. Oh no, these are skips. Okay. Yeah, opt is false. So let's just say opt equals true. Defer fun. You have to invoke the function we defer it. Opt equals false. Pass. Okay, excellent. And then for good measure, we'll run it again with short turned off. Why is my cursor not even moving? Sweet. Okay, let's just make sure I did actually fix this. Yeah, if opt, we're going to put opt in there. Carter grad, we only need points. I think we might have problems with the frequencies actually also. Let's see where this gets referenced. It never gets referenced. Okay, great. If opt. A.go. Okay. So we're going to run the optimization, and we're also going to run the frequency. So that means in make so in that case, this needs to be opt and freak, and I'll take that out as well. Alright, one more compilation. And hopefully that'll be it. So, hopefully today I got to show off a little bit more of, interaction with the compiler. Last time I was just doing something very simple that I've done many times. Today was actually new. So today I did a real refactor, and I showed off some of the facilities of projectile in doing so. I also hopefully showed you a little bit more about how to use Emacs compile. Before I go, we can take a look at my make file to see what I'm actually calling. So I can highly recommend the book Managing Projects with Make. I read that, and that taught me cute stuff like this, like referring to the target, and this is all of the dependencies. So this fills in all of these, stuff like that. Hopefully there's nothing weird in here, or private. I guess this is on GitHub, so it doesn't really matter. So you can see what I'm gonna make now is the alpha recipe. Yeah, because that's where I've been running this from. So let's go ahead and run that. So I'll just do Emacs compile. This time I'm gonna make alpha, so that's gonna build it, and then it'll copy it over to the supercomputer, where I still have that terminal open. So we'll wait for this to complete. This is also one of the things I love about Go, is it makes these nice static executables. I get to compile it locally, transfer it to the supercomputer, and it runs perfectly. I don't have to try to get Go installed on the supercomputer so that I can compile there. I don't have to do like remote. I don't have to use Tramp. I like Tramp, it's very useful sometimes. But trying to compile and stuff over, it's a real pain. So I don't have to work all the time over Tramp. I can just compile and run it. So my alias for alpha is this. So now if I run alpha version, here you can see the commit. What's my commit? And it's right, 9855749. Excellent. Actually, now that I did this, I should probably, yeah, let's. Alright, let's push that. Let's actually remake this, because that'll give us a new version. And then I'll run it just to make sure it actually goes through. Version. Beautiful. So this is Magit, or Magit, however you see it, CC8BBE1. Beautiful. There we go. And so then the way I've been running this, I've just been putting it in a script so that I can remember what I did. So I'm just going to call that alpha. This dump flag is going to dump like the energies and geometries as we go. This is my input file, and then I'm going to disown it because it's going to take a long time, and I don't want to have to keep my terminal alive for that duration. So let's go ahead and run. This time test.error is empty. Test.out. Beautiful. What? Oh, that's pretty funny. Alright, that's a very minor bug. We can survive with that. But anyway, it looks like it's running this time. Alright, excellent. So it looks like it's actually running. So hopefully you guys enjoyed that. Hopefully you can learn something from it. At some point, I'm planning to learn Rust. So these may switch to live coding Rust streams at some point, but hopefully you guys are enjoying the Go programming for now. Okay, I think that's all I wanted to do today, so see you guys next time.